welcome to another video of computer networks and security. So, according to me, computer networks and security 18 CS52 is one of the easiest subject, but the topics and the syllabus is very much big. So, understanding is very much easy. If you understand carefully, it is very easy subject. So, when you come to the first module is very big and huge module. So it is difficult to cover all the five modules with full completing the syllabus. It is very much difficult. So I have made in module 1 some 10 questions with the help of which you can get 10 to 15 marks. Okay, you can also get 20 full marks also, because most of the important topics I have covered, and which are the topics which are not necessary, I have removed those topics. Okay, so before starting on with the first module, I want to tell you something that in module 1 there is some concept known as socket programming. Okay, it is a confirmed question which can be asked for 10 marks. 8 to 10 marks, not exactly 10 marks all the time. So 10 marks. So the socket programming is for TCP and UDP. Okay, so if these two questions, if you want to study these two questions, these are very much difficult. It looks simple but are very difficult to understand. So you can study these two questions or the 10 questions which I am giving, with the help of which you can also get 10 marks from here easily. But it is very difficult to remember what you have learnt in the time of exams. So the time is less. If you want to get marks or 10 marks at least, you have to quickly we have to push forward the video at the rate of 1.25 1.2 playback speed, and you have to watch the video. We have to firstly understand what I'm trying to say. With firstly understand, and you can get easily 10 to 15 marks. Explain client server and peer-to-peer architecture. Client server architecture and peer-to-peer architecture. 6 to 8 marks. Client server architecture. The client server architecture. Uh, in client server architecture, the host that sends request is known as client. Client sends the request. The host that fulfills the request is known as server. Server fulfills the request. In client server architecture, two clients do not directly communicate to each other. See, two clients do not directly communicate to each other. They communicate with the help of servers. Client contact the server by sending packets to server IP address. The client contact the server by sending the packets to server IP address. He send the packets to server IP address, with the help of which they contact the server. Okay. For example, client server systems are FTP, Telnet, and emails. You can see this diagram. Diagram is easy to remember. Client server architecture. In client server applications, single server can't handle multiple requests at a time. So therefore data centers are used. In client server architecture, single system or single server can't handle multiple requests, so data centers are being used. So peer-to-peer architecture overcomes the drawback of client server architecture. Like in peer-to-peer architecture, the dependence on data centers are reduced. Like the dependence on data centers like Google data centers, Microsoft data centers, there are many data centers. With the help of peer-to-peer architecture, the dependence on data structure is reduced. In The peer-to-peer architecture, the host can directly communicate to each other. In client server, the host can't communicate directly to each other. In peer-to-peer, host can directly communicate to each other. Okay. In peer-to-peer architecture does not have the server. The peer-to-peer architecture does not have server, but instead have laptops and desktop. So in peer-to-peer architecture, to store the data, we don't have server. The data is stored in desktop, laptops of users, etc. Some of the examples of peer-to-peer systems are BitTorrent, Skype, Internet telephony, etc. Peer-to-peer architecture. So the second question is, explain the services offered by the DNS and explain DNS format. It is also asked for 8 to 10 marks. The services offered by DNS are the three services: host aliasing, mail server aliasing, load distribution. Okay, so host aliasing. What is the meaning of alias? Alias meaning nickname or short name, which is easy to understand. Don't write nickname in the exam, but I'm telling you to keep in mind what is alias. Host with complicated host name. See, uh, a host. Google. Say suppose Google is a host. It has complicated. Google is a host. It has complicated host name. That is google.com, www.google.enterprise.com. It can have two alias name. So we can't remember www.google.com every time. So we remember only google.com or www.google.com. So these are the alias name. So this is the complete host name. Full website name is known as host name. So as we can't remember their host name every time, so we remember only alias name. Alias name is nickname, such as google.com or www.google.com. Host aliasing is also known as canonical hostname. The canonical hostname can be obtained by an application with the help of alias name using DNS. So the canonical hostname can be obtained by an application. So canonical host names will be www.google.enterprise.com, can be obtained by an application like anything, your browser or your desktop, etc., with the help of alias name. The canonical host name can be obtained by application with the help of alias name using DNS. So the concept is simple. You can't keep remember all the full website name or full URL. So you remember some part of that URL, which is alias name, some part of the URL which is alias name, with the help of which you can get whole canonical host name or host aliasing or host name. Okay, so mail server aliasing. It is similar to host aliasing, but using emails. Everything is concept is same. It get a canonical host name from alias name, but the all the ideas are applied to email. Consider Bob. Consider Bob having an account in Hotmail, and want to send and Bob's email address. And Bob's email address is bob@hotmail.com. The canonical host name for Hotmail will be difficult to remember. So the same, it is difficult to remember bob@hotmail.com, and you interact with many people in a day, so it is difficult to remember all their emails, etc. So, however, canonical host names can be obtained by an application using alias name by using DNS. Same, everything is similar in that in host aliasing, website URL is obtained from alias name. Here, email address is obtained with the help of alias name. So load distribution. See, um, see, this is one server. So this are, say suppose this server is used to store IPL data. So if this server is about to full or it is going to full, then to maintain to store more data in the future, it distributes the load to replicated server, or the server that only stores IPL data. So these three servers are similar. It stores only IPL data. So it distributes the load or the data available with him to other servers. So this is known as load distribution. DNS is used to perform load distribution among replicated server. A replicated server which performs same task, or server which stores same data. The load distribution among multiple servers running on different system and different end system with different IP address. So suppose it distributes the data with the server running on different end system and having a different IP address. And the concept, if you understand, it is very much easy. Okay, so it distributes, this is a server. If it is about to full or it has no more memory to or storage to store the data, it distributes the data to replicated servers. The server which perform the task which is perform same task performed by this above server. Okay, so this he shares the data or transfers the data to that server which is running in a different end system and with different IP address. A canonical host name is associated with IP address. Same. Canonical host name is URL is associated with an IP address. DNS contains a set of IP address. So, what is DNS? Domain name server contains the IP address for a given host name. Okay, so if you give www.google.com to the DNS, it returns back with the IP address. So this is a perform of function of DNS. So this is what it is. DNS function contains a set of IP addresses. When a client makes a query for canonical hostname, the server responds to the set of IP address. So when a clients want the URL canonical hostname, this DNS server responds with a set of IP addresses. Okay, so whenever he asks something, if a user asks www.google.com, say he responds with all the IP addresses available for him for google.com. So what happens? But rotates the ordering of addresses with each reply. Say suppose there are two users. Okay, they both are asking for google.com. If the server has sent the IP addresses in order of 1, 2, 3, 4. So for next user, it sends IP address in the form of in the order of 3, 2, 1, and so on. So what this is what happening. It but rotates the ordering of address with each reply. This rotation helps the DNS to distribute traffic among replicated data. DNS message format. It is recommended to play the video at 1.25 playback speed. Identification DNS message format. DNS message format. It is easy to remember. In the questions related to diagrams, you have to focus on diagrams first and then on theory part. It will be helpful to get maximum marks. So identification flags. So you remember these two things: identification, flags. So now number of questions, number of answers, number of questions, number of answers, number of authority RR, number of additional RRs. So identification, flags, number of questions, number of answers, number of authority RR, number of additional RR. So questions, answers, authority, additional information. Same. Questions, questions, answers, authority, additional RR. So you focus here: variable number of questions, variable number of resource record, variable number of resource record, a variable number of resource record. All three are same. The first one is variable number of questions. So here it is 12 bytes. In questions, name, type, field for query. For in order to ask question, what is required? Name, type, field for asking query. RR in response. Resource record in response to query. So resource record is nothing but an answer. Resource record for authoritative servers. So these are records only for higher authorities. Additional information that may be helpful. So if you look at the diagram, you can easily remember it. Now we'll come to theory part. The first 12 byte are header section with multiple fields. First 12 bytes are header section with multiple feed, uh, fields. Uh, the first field is to identify a query. The first field is identifying a query. Uh, the one bit query slash reply flag. The one bit query slash reply flag is used to determine whether the message is query or reply. Okay, now compare this with these three points. The one bit authoritative flag is used to reply message. So only as the authority can reply the message. One bit authoritative flag, one bit query, or there are three types of flag: one bit query or reply flag, one bit authoritative flag, and one bit recursive desired flag. So these three have three different functions. First one is used to determine whether the message is query or a reply. The one bit authoritative flag is used to reply to messages. One bit recursion desired flag is used when a DNS wants to perform recursion. DNS wants to perform recursion. Recursion is nothing but calling a function calling itself repeatedly to perform a particular task. Questions. Uh, okay, so the next field is questions. The question contains information about the query being made, such as name, name of the query, type, field of the query. Same. It contains the information of the query being made, like name of the query, type, field of the query. The answer section contains resource record, which answers are for particular query asked. So the answers section contains resource record. Resource record is nothing but uh, answers, which are answers for particular question. So which is it's said here, which are answers for particular query asked. The authoritative server contains records for authoritative server. So this server contains record only which can be viewed by authoritative server or higher authority. The additional section contains other useful record. The additional section contains other useful record. So this is the DNS message format. With diagram explain interactions of various DNS server. Interactions of various DNS server. There are two types of interaction of DNS server. Recursive queries, iterative queries. It is asked for 8 marks. Recursive queries. So understand what is happening here. So uh, this is client. He wants an IP address. Uh, he wants an IP address for this thing. CIS.poly.tdu. The IP address is present at how we'll get the IP address we will see here. So the client requests sends the query. The client sends the query to local DNS server. Okay. Now local DNS server, if he don't have the IP address, so what he does, he sends that query to root DNS server. Okay. Now root DNS server also don't have the IP address, so he sends back that he sends the IP address of TLD. Okay. Now root server, what he does, now sends that query to TLD DNS server. The TLD DNS server also don't have the IP address, so he gets back with the IP address of authoritative DNS server. Okay, so this is what happening in the arrow marks, if you can check properly. So now what local DNS does, he sends that query to authoritative DNS server. The authoritative DNS server has the IP address for this thing. Okay, so he reverts back with the IP address to local DNS. Now local DNS has the IP address, so he return it back to the user. Okay. So this is everything. You have to write. You have to remember this. You have to write what is there in the diagram to get full marks. So this is nothing. You have to just remember it. So this is what happening here. Here the DNS query is sent to local DNS server, then then to the root server, then to the TLD server, and then finally to the authoritative server. See, you have to just remember. It is what I have said. If you understand this, you can write this easily. The DNS response arrives in a reverse manner. See, if he sends the request here, the response is also sent the opposite direction, in the reverse direction. Okay, iterative queries. So now a user wants an IP address for CIS poly.tdo. So he sends its query to local DNS. So uh, the query is not present at local DNS. So he sends the query to root DNS. Everything is same, but the directions have been changed. So now it sends to uh, TLD DNS server, and then he also further sends to authoritative server. He has the IP address, so he gets back to TLD server. TLD server gets back to root DNS server, and root DNS server gets back to local DNS server. Local DNS server finally gets back to this host client. So we look here. The query is first sent to local DNS server and forwarded to root DNS server. Now root DNS server sends the IP address to TLD server to local server. He sends the IP address of it is not shown in the diagram. It sends the IP address. It is similar to what the functions happened here. So he sends IP address of root DNS server. Oh, sorry, TLD DNS server. The TLD server. Now the server sends the query to TLD server. Okay. The TLD server sends the IP address of authoritative server to local DNS. The local server DNS server sends query to authoritative server. The authoritative server sends IP address of the host. So these both diagrams are similar. In both want IP address for a host name. So what they then they sends to local DNS. Local DNS sends to root DNS. You don't have that, so it sends the IP address to of a TLD server. Uh, The local DNS sends a query to TLD server. He also don't have the IP address, so he sends back with the IP address of authoritative server. So he sends the query to authoritative server. Authoritative server has the whole IP address, so he reverts back with the IP address. It is same. So this explanation is simple here. DNS query is sent to local DNS, then to root server, then to TLD server, and finally to authoritative server. The DNS response is in reverse manner. Okay, and here also the same thing, but the part of sending the IP address back to local DNS, it is not pointed out. So you can write it in the explanation part. There is no issues, but the diagram should include all these parts. Okay, the query is sent to local DNS. The local DNS don't have the IP address, so he sends the query to root DNS. The root DNS sends back the IP address of TLD server. Now the local DNS sends the query to TLD server, and the explanation what I have said you have to elaborate here. It is simple. Okay, now I differentiate between HTTP, FTP, SMTP, and HTTP. So whenever if you don't remember, if you just remember this thing and you don't know what, if they ask the question what is HTTP, so you can write HTTP is a hypertext transfer protocol. It is a pull protocol. It does not mandate 7-bit ASCII code. It is persistent and non-persistent connection. With the help of this, you can make some points and you can get some good marks if you don't remember what is HTTP or what is SMTP. Okay. So comparison. HTTP is a pull server. SMTP is a push server. Push protocol, sorry. And does not mandate 7-bit ASCII format. The format for HTTP, it does not mandate 7-bit ASCII format. It mandates 7-bit ASCII format. The connection can be persistent and non-persistent. The connection should be persistent only. The port number is of HTTP is 80. The port number for SMTP is 25. It transfers file between web client and web server. It transfers files between mail client and mail server. Okay. The first question is HTTP and FTP, file transfer protocol. Now it supports data connection. It only supports data connection. It supports both data connection and control connection. It does not require authentication. Authentication like encryption, decryption. It requires authentication. What FTP? It's suitable for transferring small files. It is suitable for transferring small files. It is suitable for transferring large files. It is a stateless protocol. It is not a stateless protocol. HTTP is faster, FTP is slower compared to HTTP. What is UDP? UDP is a connectionless oriented protocol or datagram oriented protocol. UDP is connectionless oriented protocol. TCP is connection oriented protocol. UDP is not reliable. TCP is reliable. UDP is faster compared to TCP. TCP is slower compared to UDP. UDP is lightweight. TCP is heavyweight. TCP is used by HTTP, FTP, and SMTP. UDP is used by SNMP, DNS, VoIP. So you can look at the compare difference, okay, between these three questions. So the fifth question. Okay, so the fifth question is explain FTP with the commands and replies. It is also for 10 marks. Okay, so what is FTP? FTP is used to transfer files from one host to another host. Okay, so as we studied earlier, authentication is used in FTP to transfer file from local file system to DNS file system and vice versa. Okay, the first user provide host name of remote file system to FTP to establish a TCP connection. So the user provides host name or canonical host name to FTP to establish TCP connection with the server. Okay, Now the user sends user ID and password over TCP connection. Why he is sending as a part of command? It is very important. He sends the user ID and password over TCP connection to the server as a part of command. Once the server authorizes the user, then the file is copied to the local file system. So once the server authorizes that user is genuine, then the file is copied to the so, remote, copied from local file system to remote file system, and vice versa. So diagram is FC, FTP user interface, FTP client. This is desktop. This is server, client, host, server, local file system, remote file system. This is file transfer, user or host. FTP uses two parallel TCP connection to transfer a file. This also we have studied earlier, data connection and control connection. HTTP uses only data connection. It also has control connection. The control connection is used to send control information such as identification, passwords, command, etc. Data connection is used to send a file. So this is diagram FTP client, FTP server, port number 20, TCP control connection port number 21, TCP control data connection port number 20. FTP commands and replies. So user command is used to send user ID to server, user information to the server. Pass command is used to send user password to the server. List is used to ask the server about the list or about the list of all the files in current working directory. It is used to ask the server about the list of all the files in current working directory. Uh, return. Return it is used to retrieve file from current remote directory. Retrieve file from current remote directory. Store it is used to store a file in current remote directory. Each command is associated with a reply. So 331. Um, the reply 331 means username is verified. Now password is required. Okay. 125 means data connection is open and file transfer is starting. 425 means can't open data connection. 452 means error writing the file. You can remember this: 331, 125, 425, 452. 125, 425, 452. Explain cookies and web caching with need diagram. So what is cookies? Cookies are used by website. Whenever you enter a website, they ask accept cookies or accept this thing. So cookies are used by website or HTTP to identify the users. So cookies are used to identify the users. So whenever if you accept the cookie, so whenever, say suppose you accept cookies on Netflix and you have watched video first episode till 30 minutes. So whenever you enter Netflix next time with the help of cookies, he he stores the data that you have watched the movie till 30 minutes. So next time he plays the video for after the 30 minutes. Okay. So this is the thing. Cookies are used to identify the users. Cookie technology has four components. These are important part. You can't skip this. You have to write it. Cookie header line with HTTP request message. Cookie header line with HTTP request message, HTTP response message, HTTP request message, a cookie file kept in users end system and then managed by user browser. Say, what is this? A cookie header line. So whenever a HTTP response message is sent, a cookie is included in that HTTP response message. This is what trying to tell. Whenever a HTTP request message is sent, so the cookie is included in that HTTP request message. So now how is the cookie managed? The cookie is stored in user send system and managed by user browser. A cookie data is stored in backend database for website. So that the cookie database is stored in database in the website. So if you look at this diagram, you can write this part on your own, working of cookie. So suppose you are the client, okay, and you want to access Amazon website. Previously you want to buy some bat or something. You have previously searched on eBay, okay. You'll understand this what it is later, okay. You have visited eBay and you want to go to Amazon to find about bat, okay. Whenever you first time you enters to at first time when you visit the Google website, you send your browser sends a HTTP request message to the Amazon server. Now the server, what he does, he creates a new unique ID 1678 for the user. So this is nothing but cookie. Unique ID is nothing but cookie. Cookie is used to identify the user. This ID is entered into the database. Okay. Now, with the HTTP response message, the cookie is also sent 1678. It is what this means. A cookie header with HTTP request message. A cookie is sent with along with HTTP request message and response messages. Okay. When this comes to back to user, the IP address, the ID given by the server 1678 is stored in user browser. Okay. So what is 8734? It is also unique ID which is given by the server when you visited eBay website. Okay. So whenever next time you visit the Amazon website, okay, the cookie is also sent with HTTP request message cookie 1678. With the help of cookie, the database can identify the user. Okay, or the server can identify the user. So you visit Amazon website the next time, he starts from previously where you have started, and he sends the HTTP response message whenever after a week or after a month also. If you visit the website, so you're using HTTP request message cookie 1678, no, the data is preserved, and you will start from the place where you have left the website. This is very much simple. The diagrams look complicated, but it is simple. If you have to just analyze what is going on. The client sends the request, he creates an IP address and stores in the database, and he sends back with the cookie 1678. It is stored in the user's browser or user system whenever the next time the user visits. So the cookie is also sent with the HTTP request message. Okay, you can perform any operation you want, and it is written back to the HTTP response message with the help of cookie. HTTP response message. Okay, it is very much simple. You have to just analyze the diagram. It is also same. You can, if you see this one time, you will remember what is going on. It is same what I have explained. User want to visit Amazon website, and that thing will web caching. Web cache is also known as proxy server. In computer organization, you would have studied about this caching. It is this is a server. So this is the user. If the user wants to access the server at a faster rate, a proxy server is placed in between, which is a copy of this original server, with the help of which user can perform the operation in the faster way. Web cache is also known as proxy server. So this is a proxy server. Web cache. See this. These are the original servers. Okay. So this concept is same. The client contacts the proxy server to faster process the data. So here it is HTTP request message and HTTP response message same, because they don't have place. I have not write it here. No, wrote here. So this is HTTP request message. This is HTTP going marks is request message. Coming arrow mark is response message. Okay. Proxy server is a network entity used to satisfy HTTP request message on behalf of original server. So this is the HTTP request message. The proxy server is a network entity that fulfills the request of the client on behalf of original server. This supports you are requesting an object from www.vtu.ac.in. The browser establishes a TCP connection with web cache or proxy server. Okay. The proxy server check whether it has a copy of the object or not. Say suppose you want some objects from VTU.com, you contact the proxy server. So if the proxy server checks whether it has the object we have asked or not. If it has of the object, it return back to the client with the object. If it does not have the object which you have requested, then he goes back to the original server. He takes the object. So the original server then sends back to the object to the proxy server. Now proxy server, what he does, he stores the object first into its system and then sends back the object to the client. Here in this process, the proxy server is acting as client as well as server. This will be important question. If you highlight it, you will get confirm marks. You can also, the question can be asked like, how proxy server act as both client and server. You can explain this process. This is the same thing what I have showed. It after receiving the object, it stores the object first and then sends the object to browser along with HTTP response message. If you see one time, you will remember. So it describes HTTP persistent and non-persistent connection. So we'll understand what is non-persistent connection. So this is the client, this is the server. So this is the client, this is a server. In order to separate TCP connection must be established for request message as well as for response message. This is known as non-persistent connection. See, a separate TCP connection is established for HTTP request and response messages. This type of connection is known as non-persistent connection. When single TCP connection is used for HTTP request and response messages, then this type of connection is said to be persistent connection. HTTP with non-persistent connection. Say suppose a website has a basic HTML file and 10 JPEG images. Then the website in total have 10 or 11 objects. Sorry. The URL for the website is vtu.com/result/view. Now client establish a TCP connection with the server. The client send HTTP request message to a server via socket. The request message includes, so this is the object result/view. This is the location from where we have to obtain an object with the clients and this object along with HTTP request message. Now the HTTP request server receives the request message via sockets and retrieve the objects from result/view from the storage. So the server receives the request message. They also receive this location from where the object is retrieved and sent back to the client. Then encapsulate the object within HTTP response message and send it back to client. So uh, the object is merged with the HTTP response message and sent to client. The client receives the object from HTTP response message and terminates the TCP connection. What happens in TCP connection? Like if you have shared one file, one image to the client, then the connection is terminated. So there are 11 objects. So it is very much difficult. So 11 times TCP connection has to be established so that to complete one task. So this is what happening. See, you can memorize this diagram. This is nothing. It is simple. If you identify establishment of TCP connection, RTT request file, RTT entire file received, time taken to transmit file. You can remember this diagram. So what is RTT? RTT is round trip time, time taken for the packet to go to server and back to client. The time taken to the server to go to the server and back to client. Time taken for a packet to travel from client to server and then back to client. RTT has packet propagation delay, packet queuing delay, and packet processing delay. RTT has this type of three types of delays. HTTP with persistent connection. The drawbacks of non-persistent connection are there are many drawbacks of non-persistent connection. Say a brand new connection must be established for each objects requested. Okay, what I have said, and each object suffers two RTT delays. Okay, one RTT delay is used when TCP connection is established happens. Another RTT delay happens when the object is used to when an object is retrieved. In persistent connection, the server leaves the TCP connection open after the sending the object. So the drawback is eliminated. So when one object is shared, the TCP connection is not terminated. The HTTP request message and response message can be used to send over same connection. In that, different TCP connection are used to transfer a data. In persistent connection, multiple web page can be sent to client over the same connection. Okay, so eighth question is HTTP request message and response message format. It is asked for 10 marks. So just look at the diagram. So what is the diagram? Method, SP URL, SP version, CRIF. CRIF is present in all the last part. CRLF. Okay, so now just look. Method, there are three main functions or anything. In between this, SP is present. See, SP is present. Method URL version. So request line, header line, blank line, entity body. This is same. Okay. Now header field name value, header field name value, CRIF, CRLF. Okay. To compare this with HTTP response message. So there was request line, now it became status line. So these three words, these three namings are same. So what was there here? Method URL version. Okay. The only difference here is version status code phrase. Version status code phrase. The rest all things are same. Okay. The request line and these three methods have been changed. If the questions for HTTP request message and response messages are asked for 10 marks, and if you draw these two diagrams only, you can get at least 5 marks. Okay, so that's why I'm telling you the diagram. The only difference is the first lines. Okay, where SB is space, CR is carriage written or written, LF is line feed methods. There are 5 HTTP commands. Get method is used to is used when a browser requests an object. Okay, get method is used to request an object. Post method uh, is used when the user enters the data. See, the post method is used when the entity body contains the data entered by the users. Okay, the post method is used when the entity body has the data entered by the user. Put put method is used by application to upload an object to the web server. To upload an object to the web server, head method is used to debugging purpose. Head method is used for debugging purpose. Delete method is used to delete objects of web server. URL. So URL field. See, First, we have studied about method field. We are studying about URL field. URL contains URL of the requested object. Next version, that fields contain the HTTP version, whether the HTTP version is 1.1 or only one, etc. Header lines, and you have to write this example: host www.vtu.edu, connection close, user agent Mozilla 5.0, accept language FR. So HTTP response message, the only difference is status line. In request message it is request line, method, URL, version. So here it is version, status code and phrase, CRLF. Everything is same, rest all is same. Consider the following example. So you have to remember this. Okay, HTTP 1.1 200. Okay, connection close, date, server Apache, last modified, content length, content type, etc. The status line has three fields: version field, status code and phrase field. Okay, and the server uses TCP connection close to terminate TCP connection. So we are explaining this code over here. Okay, the server uses TCP connection close to terminate a TCP connection. The date. This line contains date and time when the HTTP response was made. Okay, when the response was made, it represents the date and time. The server field indicates the server being used. Which server we are used, like Apache server. The last modified field contains the time and date when the object was last modified. The content type indicate the object type, which type of object it is, whether it is a float type or integer type or large type, etc. The common status codes are, okay, 200. It indicates that the user request has been accepted. 301. It indicates that object has permanently moved to new location. 400 means the request is not able to understood by the server. 404. The object requested is not present in this server. Explain SMTP with need diagram. SMTP transfers message from sender's mail server to receiver's mail server. Okay. Suppose Alice want to send message to Bob. Alice invokes his user agent and sends the message to Bob by providing his email address to his agent. He first invokes his agent and he then provides him with the Bob's email address, and then the message is placed in Bob's mail server. When he provides the message to his agent, then the message is stored in Alice mail server. Now the Alice mail server in Alice mail server, okay. The SMTP client established a TCP connection uh, with the server. So this is the client, he is a server. The SMTP client established TCP connection with the server. After some initial handshaking, the SMTP client sends Alice message to Bob mail server. So this is the client, this is the server. After some initial handshaking, he sends a Bob message and places it in Bob's mail server. Now the Bob mail server sends the message to Bob's agent. Now whenever the Bob want to read the message, he can do it by invoking his user agent to read the message. So this is the 10th question. Explain various transport services and also explain the working of DNS. Well, the four types of transport services. Importantly, reliable data transfer. So packets. This is a source. This is a destination. When so in many cases the packets are get lost. Packet are lost. Okay, the packet can be lost due to buffer overflow or when the bits getting corrupted. Data loss in application. Whenever the application data is lost in the application such as email, financial services, it can provide multiple consequences to the application or to the user. To support this application, someone has to guarantee that the transfer of data packets to the destination. So if someone has to guarantee that the packets will go to the destination, okay. If any protocol provides this service, we say that is providing reliable data transfer. Okay, if transport protocol is provide this service, then it is guaranteed that data will arrive at the destination without any errors. Okay, if transport protocol provides this service, then we guarantee the data will arrive at the destination without any errors. If transport protocol does not provide this service, we infer that some of the packets may never arrive at the destination. Okay, so when transport protocol sends provide this service, we can guarantee that the packets will arrive at the destination without any errors. When he does not provide the service, then some of the packets can never arrive early. So next one is throughput. Throughput refers to the amount or unit of information processed in a time. So in a given amount of time, how much amount of data has been processed. This is throughput. throughput. Throughput refers to the rate at which the message is being delivered. Or you can write this anything, or you can write both. Refers to the rate at which a message is being delivered, the speed at which the message is being delivered. Okay, transport layer guarantees the available of throughput at some specific rate. Okay, transport layer guarantees that throughput will be available. Throughput means the amount of data transferred in a minute or given amount of time, or which amount of rate of which the data is being transferred. And transport layer does not provide this service, then application have to encode at a lower rate. Say if throughput is not available, the data should be transferred in slower rate. Okay, throughput. An application that use throughput are known as band sensitive. Okay, in this band only this throughput applications work. Elastic application can make little use of throughput. Like elastic application, no need high use of throughput. They make use of little use of throughput. These elastic applications are email, file transfer, web transfer, etc. Are all elastic application. Transport layer protocol also provide timing guarantees. Transport layer protocol also provide timing guarantee. Real-time applications such as internet telephony, virtual environment, multi-layer games, etc. require timing constraint. That is, um, when a reflection in the one server, when a reflection no changes in this data is made, then it must be reflected to the server immediately. Like financial application, when you have withdrawn 100 rupees from your bank account, then it must be immediately reflected to the bank server. Okay, for the in order to be effective. This is what I have wrote. Real-time applications such as internet telephony, virtual environment, multi-layer games required timing constant on data delivery in order to be effective. If this is not effective, then if timing constant is not provided, then the server will not know that the data 100 rupees has been withdrawn. So in real time, if it is not reflect, then you can remove hundreds of rupees, and the bank will not ever get to know. So this is important. Security. Transport layer provide application with multiple security. The security is provided in form of in concept of encryption and decryption. the packet from the server end, the packets from server end are encrypted and sent to receiver at receiver end in order to maintain security. The packets from server are encrypted and sent to client are encrypted and sent to server in order to maintain security. In different types of security, there are different types of security of transport protocols such as confidentiality, data integrity, endpoint authentication, etc. Working of DNS. DNS is known as domain name server. It has the IP address of a host name. The domain name, host name of Google.com. The host name Google.com has an IP address of this thing. The IP address can be anything. Now, when a user needs an IP address for a host name, school.edu.com, the browser sends the host name to DNS application. The browser sends the host name to DNS application. So in DNS application, what are the things are happening? We'll understand it here. In DNS application, the DNS client sends the query about the host name to DNS server. In DNS application, the DNS client sends the query to DNS server. The DNS client gets the IP address for host name DNS server. Sends the query to the server. Now the server gets back to the client with the IP address. The DNS clients forward the IP address to the browser. So this is the working of DNS.